Now, one thing that the master's degree has taught me, and now learning it even more deeply as I do my PhD, is that the way we used to memorize things, I don't know if it's just me, yeah, but I know those, especially when we were in high school and at the BSc level, we used to do a lot of cramming. Like you're preparing for exams and you're cramming and you can actually say word for word, yeah? And we passed exams at that level. But unfortunately for a master's program, now you're introduced to critical thinking. It's not just about memorizing. In fact, the things that you'll be reading because you're reading extensively, you cannot be able to memorize. Good morning, good afternoon, good evening from wherever you are watching this video from. Welcome to myLAB Life with Lucy, and I am so glad that you joined me. Thank you so much if you are coming back, and thank you even more if this is your first time in this channel. Welcome so much, and in Kenya we say karibu sana. So in today's video, I want to talk about what it really takes to do a master's degree in a laboratory-based career. Yeah, and I'm so glad that we are coming to the end of 2025. I think this is the last vlog. Yeah, today is 29, but I don't think we can be able to do anything more. Yeah, so thank you so much for always being here. I hope you've been learning a nugget or two throughout the year. And if that's the case, subscribe if you haven't, and kindly like this video, share and comment. Okay, so now for us who are new, I am a doctoral fellow who has been pursuing a PhD in molecular biology, and I'm actually towards the tail end, and I know that come 2026 I will be graduating and finishing off, and that is a story for the next year. Yeah, I'm doing my PhD in molecular biology. I did a master's degree in 2019 in molecular biology and biotechnology. And before that, I had done a bachelor's in medical laboratory science and technology. So you're in the right place if you want to know how and what it takes to pursue a master's degree. So the very first point when it comes to undertaking a master's degree of any kind is academic requirements. So in laboratory-based degrees, we are talking about careers that span medical lab science, biochemistry, molecular biology, microbiology, biotechnology, biomedical sciences, bioengineering, and so on. Yeah, so for you to do a master's degree in any laboratory-based course, at least you have to have any degree in any of those areas and any other related areas that I may not have mentioned. Usually the minimum grade requirement for majority of these courses is a second upper class. Yeah, of course you need to have graduated so that you can present your academic transcripts. And then we have some universities that may require you to do some entry exams, especially if you're going to do your master's under maybe a scholarship scheme or some funding scheme. You may be required to do some entry exams to certify maybe your laboratory skill experience. Strong grades open many doors And I will encourage, if you haven't graduated, kindly work on your grades, get the best, second upper, first class and all that. But as much as that is important, the whole story is coming after this. Yeah, so do your part, but there's still a lot that we need to do as pertains a laboratory-based career. Now, another critical point that is beyond the grades is your skill set and mindset. Now, skill set, because it is important to see what it is that you have more knowledge, background knowledge about. Yeah, because as I have mentioned, we have a range of many laboratory-based courses that can be done at master's level. So it's good to know, okay, will I do a specialization in molecular biology, immunology, biostatistics, bioinformatics, microbiology, or which particular area am I actually going to get into? And that can be based on mainly your foundational knowledge and also genuine passion for that particular area. And then, of course, master's programs and any postgraduate program, usually you have to learn how to work independently. Nobody's gonna follow you. There's a bit of low supervision. Yeah, so usually what it requires is that be able to work independently without supervision so that you can fast track your work. Because these programs are mainly self-paced. Well, you'll be told the master's program is 1 to 2 years, but you know that people who graduate after 5, 10 years, because they are not able to manage either their time or they don't have self-discipline. So anytime we talk about education, trust me, it's not easy to go back to school after you have done your bachelor's degree. It is never easy because many things have changed. You probably are working, probably have started a family. There are many other conflicting things that may come in between. So it's good to really know how to work independently with low supervision, have self-discipline so that you can complete your work on time. Now, another thing which I wasn't very good at is being able to read extensively, especially reviews, journal articles, books and all that. And there is a lot of reading. Yeah, and I have one big problem of not being able to read things on my screen, like my phone or my laptop. I don't know who else is as traditional as I am. I'm more able to do reading if I have like physical copies. That is why you can say I have a file even now. Because what I do is, if I have like some journal papers that I really feel are important, maybe I've read the abstract and I feel they're important for the study that I'm doing, then I'm gonna print. So that once I have printed, then it becomes easier for me to go through the paper, underline what is important, and that way get all that I need from it effectively. So reading is gonna be hectic if that hasn't been your strength, but if it has, then you have an advantage because there's a lot of reading that comes in when you do a laboratory-based master's program. Then you must also be able to write. So these journals that we are reading have been made by people who are research assistants, who are postdocs, who are master students, PhD students, and that means that you're also on that road to being able to write. And this will start from essays during your coursework, you'll go to proposal writing, and eventually writing a scientific paper or your research findings. So if you have probably some experience in it, good. If not, expect to do that. Now, one thing that the master's degree has taught me, and now learning it even more deeply as I do my PhD, is that the way we used to memorize things, I don't know if it's just me, yeah, but I know those, especially when we were in high school and at the BSc level, we used to do a lot of cramming. like you're preparing for exams and you're cramming and you can actually say word for word. Yeah, and we passed the exams at that level. But unfortunately for our master's program, now you're introduced to critical thinking. It's not just about memorizing. In fact, the things that you'll be reading, because you're reading extensively, you cannot be able to memorize. You get exhausted. So you need now to start understanding, critically analyzing papers, because as a researcher, now you start to question and see what is a mistake with someone else's work, or what are the research gaps that are there, so that you can now work on them. Yeah, so a master's degree trains you to think critically and not just to memorize content. Point number 3, which you may have or may not have at this point before you begin, is research exposure. Now, if you have some research experience at some point in your BSc, this gives you an added advantage, because this will include things like having some good hands-on laboratory skills. Probably you've done some good experiments. You've also probably done an internship already before you think about a master's program. You're working in a research institute. You're working in a hospital. So hands-on laboratory skills, or basic research methods like how to write proposals. We also have some data analysis skills like statistics and field methods. Yeah, and also if you have some scientific writing of reports, proposals, and abstracts. If you have this beforehand, they'll give you an added advantage. But if you don't have, then we said our mindset is that of learning. So we're going to be prepared to learn hands-on laboratory skills, data analysis, research methods, scientific writing, and all that. Now, another thing that is very important to think about before you can apply for a master's degree program is that we will need to do a lot of presentations. So we need public speaking, or what we call in science communication. Yeah, science communication skills. And this will involve being able to, first, once you have generated your research proposal of this is what I want to do, I'll be answering this research question, then you'll be required to defend in a panel of other scientists and lecturers and other stakeholders. You'll be required to defend your work. So that's the very first one that we normally do, being able to defend your proposal. Then after that, there is what we call progress reports, where now you have started your work, gone to the field, you're doing your laboratory work, and there's those results that you're getting. So we need to present them to our peers and to our supervisors. And that is also public speaking. And then we also need to, once we have done our research findings, we have our conclusions, we have probably generated a research report or article, then we need to present this in our lab meetings as well, and also in conferences and workshops. So throughout the process, the whole process of a master's student and also PhD student and going ahead involves a lot of presentations. So you learn in the process, and I think that has really taught me so much to be able to clearly explain what you want to do, how you want to do it, what you found, and what are your conclusions, and what do you recommend for other researchers who will come after you and they want to continue the work that you're doing. So research exposure and a good mindset, I've realized, helps us to strengthen whatever applications we make, and also build your confidence. So start early. For example, if you haven't probably started your master's degree, then ensure that you're somewhere in a research institution, either working or volunteering. Then these days we have AI, we can learn biostatistics, we can search how to make a proposal, just have those skills start reading articles, and that you even have ideas of what you could actually do in terms of your proposal. Number 4 is the point that I feel is extremely important, that is resources and support. Now, this is very critical because before you plan to begin a master's or a postgraduate course, and any course in general, even a BSc level, you always have to think about the money. Where do you get the tuition fees, the project fees, and also living expenses? So it's good that you plan before whether you want to either fund your education entirely or you want to rely on grants and scholarships to be able to fund. And I'll be creating another video to explain how you can actually fund your postgraduate studies. I personally have gotten scholarships to fund my education, and that has made it a bit easier because when everything is catered for, then it means that you're only giving your time, your commitment, and that means you also graduate on time. So I'll do that in another video and explain exactly what are the various steps that I took to ensure that I am fully funded for my master's program. Now, there is what maybe I can mention even now, that we have what you call a research ecosystem, especially in laboratory-based careers, where we have like what you call a principal investigator, a PI, who is usually mainly a postdoctoral fellow. So these are individuals who are able to get grant funding for various projects. So they write proposals and they get grant funding. Now, under this funding, a majority of them will require that there will be a doctoral fellow, that's a person doing a PhD, there will be a master's fellow, and there will be research assistants who have just finished their BSc. And that means that if you join such a research ecosystem or group within a university or a research institute, it means that your project fees will be catered for under the grant. Now, some could also be catering for the tuition fees, either fully or partially. And some may be not catering for the tuition, but at least the project is catered for. So you can see that there are different levels, and now you can get the opportunity depending on what you are able to do. Yeah. So if you have some money, you can pay for your tuition, and then the project is catered for. If the grant is able to pay part of your tuition, then you pay part of the tuition. The other half is catered for by the grant as well as the project. If you are lucky, you'll get one that fully caters for tuition and fully caters for your project. So it's good to explore. And I usually say, especially if you have just finished your master's, not master's, if you have just finished your BSc, look for a research institute or look for a principal investigator who has a grant. Volunteer, do an internship, do an attachment, and start at a research assistant level and grow upwards. And that way, you're also exposed to opportunities of applying for programs either locally or abroad. You also need emotional and social support from family and friends. Sometimes going back to school is not very easy. It demands a lot of time, a lot of focus and sacrifice, and sometimes we are doing it in the midst of other work obligations. Then you also need good infrastructure and environment, and this is now the lab, the field where you want to go, and it's gonna be easier if you have actually become part of a research ecosystem or group, like I had mentioned earlier. Now, the last thing is time commitment. Well, I know this, we are completely aware that doing a master's program, doing a postgraduate program, it requires a lot of time and sacrifice. Yeah, most of these programs will be said will be 1 year to 2 years, but as we know, the reality of the matter is that a majority of the time we take more than the 2 years. We even take worse of 5-10 years to complete a master's program. Well, it could be based on many things that may have come up, or also personal reasons. But it's good to be prepared that you commit and finish it within the stipulated time. And usually to involve just maybe the first year having coursework, or maybe one semester having coursework, and then you're introduced to making your proposals for the projects that you want to do, so that you do that for the next year. So it can be intense, but if you're ready with all the things that we have said, then you make it. So now, a master's degree is not just about upgrading your qualifications, especially in laboratory based, because there is a lot that you're learning, you're doing new projects, and like I mentioned, it is not the same as other careers, yeah, where it's just more information that is being added, yeah. So, and then they're getting more qualifications. In this one, it's a whole turnaround. I can tell you, the BSc person I was is not the same I am now, yeah. I have learned so much, I have transformed, I have changed, I have become a different person, and now I'm in the capacity of doing even greater things in research, in teaching, in academia, and so much more, yeah. So it will involve you building your competence, confidence, and clarity in this laboratory career. Because sometimes at BSc level, you don't even have facilities in the university, so you're not able to have hands-on skills. But when you get to do a master's program, now it is mandatory. You find yourself in a system where all those things are happening. So it becomes more clear and you become more sure. And that's why you find you do a master's degree, and the next thing you're hungering for is doing a PhD, and the next thing after the PhD is doing a postdoc. And after that, you become a PI, you look for your own grants, and now start mentoring others within the research ecosystem. I hope you learned a thing or two. Be waiting for other videos that will come. I'll talk about PhD, I'll talk about my own journey, especially in funding and scholarships, and I will talk about any other thing that you want to ask me. So kindly write a comment if you have any question. Write me the question in the comment, and then I don't know if you remember, but like this video, and subscribe if you haven't. Subscribe if you haven't, so that our content can get to as many people who can get help. So until next time, I want to say stay curious, stay consistent, and keep growing in science. And happy 2020.